Welcome to my GenAI Capstone QueryWise. In this project, I have built a GPT-powered assistant that understands insurance policies and answers questions with clarity and source citations. Insurance documents are lengthy and complex. Customers often get lost in jargon. My project solves this by reading documents and answering questions like a smart assistant. I have used GPT 3.5 for generation, OpenAI embeddings for semantic search, and ChromaDB for vector storage. The architecture uses Retrieval-Augmented Generation or RAG. Here is how it works. PDF documents are split and embedded. When a query comes in, the system searches semantically, re-ranks with the cross-encoder, and GPT answers the question with references. The project uses at least 4 GenAI capabilities: document understanding, retrieval-augmented generation, embeddings, and structured output with source citations. Parsing PDFs was tricky due to formatting inconsistencies. I had to clean a lot of junk characters. Also, re-ranking slowed the pipeline but improved the accuracy. Here I upload a sample HDFC life policy, and I have asked query, how is the survival benefit structured under this plan? And the bot replies with a clear summary and a source. Let me walk you through key code blocks to understand how this bot was developed. I will share the link to my Kaggle where this code is uploaded. Before we begin invoking generative AI capabilities, we configure secure access to OpenAI's API by reading a local token. This is a necessary setup that enables RAG and intelligent question answering downstream. In this block, we set up our ChromaDB vector store using OpenAI's embedding model. Each insurance document page is embedded into high-dimensional space and stored alongside metadata like policy name and page number. We ensure no duplicates are added, keeping the system scalable and efficient for long-term use. This is the foundation of our retrieval-augmented generation pipeline, allowing user queries to be matched with relevant document segments in milliseconds. This section implements the heart of our GenAI search logic. When a user enters a query, we first look it up in a lightweight vector cache. If it's not found or the match confidence is low, we fall back to the main insurance collection using a full semantic search. This result is then cached for future use. This caching mechanism, built with ChromaDB, ensures that repeated queries are written almost instantly without compromising accuracy. This smart fallback structure simulates the behavior of real-world search engines, fast, memory efficient, and capable of learning from user interactions. While semantic search retrieves relevant policy chunks based on cosine similarity, it often lacks fine-grained semantics understanding. That's where the cross-encoder model comes in. It scores the relevance between the user's query and each document chunk in a pairwise manner using deep contextual embeddings. This re-ranking phase fine-tunes the top results by scoring them more precisely. It ensures that the most contextual, rich, and relevant chunks bubble to the top, significantly improving the final answer quality. In this function, we leveraging OpenAI's GPT-3.5 turbo model to act as an intelligent assistant for insurance policy documents. This assistant is given two things: the user's natural language query and the top three retrieval document snippets from a vector database. The prompt is crafted using few-shot prompting. It includes multiple formatting instructions, such as citing policy names, using tables where applicable, and keeping the response customer-friendly. This setup also reflects a classic RAG pattern, where retrieval augments generation, ensuring the LLMs provide grounded and factual accurate responses. The structured nature of the prompt ensures controlled generation, making the assistant reliable for customer facing applications in the insurance domain. In this step, we generate a context-grounded answer using GPT-3.5, the user's query, along with the top three retrieval documented snippets are passed into the generate response function. We have crafted a detailed prompt that ensures citations, tabular formatting, and concise answer aligned with insurance policy queries. This is the core of our RAG-based response generation. We define a simple yet powerful function that allows real-time interaction with the GenAI assistant. By prompting the user for questions and feeding them through the RAG pipeline, we can evaluate the quality, structure, and factuality of generated responses. This mimics a real customer support scenario in the insurance domain. This is how the query and response looks like. Here is an example of our assistant answering a query about hospitalization exclusions. The model first retrieves the top matching sections from a set of insurance policy PDFs, then passes them along with the user's query to GPT 3.5. As you can see, the response is not only relevant and accurate, it also reformats text into a table and cites the exact policy name and page number. This shows structured output, document understanding, and grounding in retrieved content, key Gen AI capabilities. Now let's talk about few challenges about the RAG systems. In this block, we tackle a key challenge in any vector-based RAG system: duplication. We extract existing IDs from ChromaDB, then filter out documents already embedded. This ensures we only add new content, optimizing both memory and retrieval accuracy. It's a small detail, but incredibly important for production grade Gen AI pipelines. This block initializes the brain of our chatbot, a vector database using ChromaDB. Each document is embedded and saved along with metadata like the policy name and page number. These metadata fields allow our assistant to cite specific documents, making the output both explainable and grounded. This function extracts the intelligence buried inside complex policy documents. It not only captures paragraphs but also extracts structured tables while maintaining their reading order. This data is then stored as text plus JSON chunks and forms the input to our RAG system. It's a crucial piece in document understanding. In the next step, we loop through a directory of policy PDFs and apply our extraction logic on each. This is an important MLOps and document automation step, setting the stage for scalable GenAI ingestion and retrieval. By preserving document names and page numbers, we ensure all answers are grounded in source context. Next, I want to add voice queries using Whisper and maybe let users upload audio policy briefings. More importantly, I would love to fine tune the responses for Indian insurance terminology. Thank you for watching. QueryWise was built to simplify insurance for everyone, blending deep domain understanding with GenAI superpowers. Thank you. More at the GitHub link and the Kaggle link as well. Thank you.